welcome all the participants of this special course for school teachers. Today's session is an experiment on reading satellite imageries for information extraction. So before starting the experiment, I thought we will have first a small background of theory, how to read the satellite image for information extraction. And then when we will come to the hands-on on satellite image processing and visual interpretation. So the content of this presentation would be what is satellite imagery, how it is captured, the characteristic resolutions. I will only skip fast through them because in the morning you had an excellent session by the IIRS on the Earth observation, satellite and remote sensing program. Then we will come mainly to our reading the satellite imagery or basically interpreting the satellite image, and then how we can process the same image using digital image analysis, and we will see some examples. So in the morning session, you have been told about what is remote sensing. Remote sensing is technique of acquiring information about an object without being in physical contact with the object. And in context of Earth observation, we are doing this by measuring the portion of electromagnetic radiation reflected or emitted from the Earth's surface. Right? So the basic principle is that we have an energy source. That energy source travels through the atmosphere and reaches our target, which is our Earth surface. And this energy, when it is reflected back or it is recorded by the sensor, which is on board a satellite, right? And the satellite is orbiting around the Earth. And whenever the satellite is in the contact of a ground station, this data which it has recorded is sent to the ground station. Now, from the ground station, this data comes to the users or analysts. The people who are trained in interpreting satellite imageries, people who are trained in processing those satellite imageries. So it is this experiment that we have to do this stage. That means the data from ground station, the data has been recorded by the satellite and sensor. It is sent to the ground station. From the ground station, we have taken the data and we will process it or we will analyze it. And we will analyze it for some application. We'll analyze it for some application. We will either make a land use map, a forest map, or wetland map. So this is the main crux of remote sensing satellite Earth observation. In the morning session, you have been told about two orbits, geostationary and sun-synchronous. You have been told that geostationary satellites are mainly used for the weather and the communication. And for Earth observation, we are using the sun-synchronous satellites. So these sun-synchronous satellites are acquiring information about the Earth's surface periodically, right, over a given area, and it is you can say there's a repetitive coverage of the Earth, yeah, at the same local sun time. I will not go into the technology because it has been covered in the morning session. Then in the morning session also, sir has told you about the resolutions, about the sensor which is recording the data, what are its resolutions. The spatial resolution, referring to the smallest size of the image, the spectral resolution, the that means the number of wavelength bands in you can say in simple words, radiometric resolution, the difference in the brightness values, and temporal resolution, which is the periodicity. So these have been told to you in the morning session. So now we can come directly to our experiment, reading satellite imageries. Now satellite imageries, reading satellite imagery, the term is called as image interpretation. So image interpretation is defined as act of examining images to identify the objects and judge their significance. So this is image interpretation. Act of examining images to identify different objects in that and judge their significance. So this interpretation can be done visually or it can be done digitally. That means on a computer through processing. Right? So when we do visual image interpretation, we use certain elements of interpretation. What are those? I have listed here, but we will be seeing the examples of these elements of visual interpretation. So like for example, if you are seeing this image, you are seeing some circular tanks. Right? They are circular, so there are some circular objects. So that means a shape is coming into picture. You can see the shadow of this circle. That means it's a heighted object, right? So we have, you see that we are talking about shape, we are talking about height, we are talking about shadow. Now there are some green colors also here. There is some green color also here. So that means we are talking about the color or the tone, right? And they're arranged in either in a linear form, like you can see here there are 6 tanks in a line, and here there are 4 circular tanks. Now I will not call them circle because I know there are heighted objects and there is shadow, so it's a tank. So there are 4 circular tanks here arranged in a matrix, kind of, you can say, in 4 quadrants, right? So we are using certain elements of interpretation to identify what are these, right? These objects, right? So these elements of interpretation are tone or color, shape, size, pattern, texture, shadow, association, etc. Now, can you judge what is this? If somebody can judge this picture here on which I'm rolling my mouse, if anybody can judge what it is, this the object, right? I'll come to it in the subsequent slide. You can use various elements of interpretation. Maybe you can write in the chat box what are these, what is this object, right? If you can identify different features here based on these elements which are. So in quickly I will come to these elements of interpretation. So first element is the tone. So tone is also the color. So if it's a black and white image, your image will be a grayscale image. White objects reflecting total energy. Dark objects do not reflect any energy. And there are some gray objects. So tone also helps in distinguishing certain features. When it is colored image, it is very, very easily to interpret, right? If it's a true colored image, you see vegetation as green. So that means whatever is green here is vegetation, either grass or trees. Then you can also see some pattern of houses, the bigger buildings and smaller buildings. So there are, and the colors are different. Now what happens is, when we are interpreting an image, we are not only using one element of interpretation. Like at present, my screen, I'm only told you about the color. But there are many other elements of interpretation which you would be simultaneously using. Like for example, the size. The bigger buildings may be some industries or maybe institutions, and the smaller buildings may be houses, apartments. Similarly, here, if you can see that the roof's character may be different from for the residential houses and for the industrial buildings. Now you can here easily see that these are pattern of roads, flyovers, right? Flyovers, you can see the shadow. You can see vehicles on the road. So we are not using only one element of interpretation. This may be a bridge, right? You can see the shadow, and this may be a canal. So we are not always using a one element of interpretation. We are using a number of elements of interpretation. But theoretically, we have only seen one element as present, which is basically tone. So what are the other elements? Shape. So shape refers to the general form, the structure, or the outline of objects. Like you can see here, linear roads. You can say these roads are linear. Rectangular buildings. So you're associating a form. In the previous example, we have taken a circular tank. So we are associating a shape for the object. Then we have size. size of an object is also a function of the scale at which you are displaying the image, right? So you have smaller objects, you have larger objects at a certain scale. Like now here you can see in this one image, we have displayed only one scale, and there are bigger aircrafts, there are smaller aircrafts, right? Maybe there are helicopters. Shape of the airplanes is also different in the case of bigger aircrafts and smaller aircrafts. So shape, size, tone, texture, pattern, etc. are the elements of interpretation. Pattern, then pattern, you know, it is a pattern. That means an arrangement. Pattern is an arrangement. So it's an arrangement of how the visible objects are placed. So you can see this is it must be an orchard where the trees are planted in a pattern. So yeah, orchards, you have evenly spaced streets, evenly spaced trees, and you have urban areas with streets at regular patterns and houses. So texture. Now texture refers to arrangement of frequency of tonal variations in an area. Like you can see here, if you associate this area with a pattern of trees arranged in a specific with a specific distance, what is this? These are also trees. These are also trees. Now here they are arranged in a pattern. Here they are not arranged in a pattern, but they are exhibiting a texture. They are exhibiting a texture. This is more rougher texture than this is smoother texture in the same scale. So next image, you can see this example of tone or color, texture, shape, size, and as well as pattern. Now here you can see that there are many green colors here. So tone or the color is green, but you can see this is a grassland, it's so evident, and these are trees. These are trees. So the texture of trees is different from the texture of the grassland. Similarly, there is a pattern of streets and there is a pattern of houses. Now, there is the size of house and the shape of house. Bigger houses, smaller houses. Bigger houses, bigger buildings, maybe institutional buildings or industrial building. Smaller buildings, maybe residential buildings near to those, I think. Very bigger buildings, maybe warehouses and so on. So all these, so whenever you are interpreting an image, we are using different elements of interpretation. Right? So shadow, in the previous example also in the tanks, we saw the shadow. So we assume that it is not a simple circle, but it is a heighted object causing in shadow. So it must be a circular tank. So here also you can see some buildings are casting shadow. So from the shadow, you can make an idea of the height of the object, relative height of the object. Yeah, for example, this shadow is longer and this shadow is smaller. So you can say that this is more taller building and this is a smaller building as compared to this building. Right? Whereas this building is a very, very small building, it is having a very small shadow. And you can see that shadow is giving me an idea of the height of the object, but this shadow is also obscuring the interpretation of this building. Had this building not been extended till here, this building would have been totally engulfed here. So shadow aids in interpretation. Shadow is also a hindrance in interpretation. Right? So now I've come to this image, right? So now you can see that if there is a large number, there is only one circular tank, it could have been water container or water storage tank. Large number of tanks may be a oil storage depot because there are number of tanks and there are number of buildings nearby, maybe processing buildings, refineries and so on. Right? So you are making an interpretation that it may be an oil storage depot because of the association. Association takes into account the relationship between the object and its nearby features. Like for example, can you identify this pattern of what is this object? Anyone? Maybe you can write in the chat box so that each one of you understand that what is this object. Now, can you see these linear features? Right. So these linear features, these are the trains. And this is a railway station. This is a railway station. There are pattern of railroads, you can see here. And had it been only one railroad, it was a railroad going from across this village or a city. But now there are pattern of railroads, and there are a number of trains with some platforms near the front of this. So it may be a railway station. You can also see the foot over bridges. So it may be a railway station. Then this is a major road. This is a major road which is going. This is a major road which is going. And there is the train. So railroad. So now if you can see that there is a shadow here. So that means there is a bridge. So this railway is going underneath. So you can also see that there is a big playground in the area. The playground is in the area, and there are pattern of small houses, bigger industrial buildings, etc. So these are different elements of interpretation which we use to identify different objects. Right. So now here I show you the image of Cartosat-1 satellite, which was a 2.5 meter spatial resolution, a panchromatic image. So in a panchromatic image also you can use if you are visually interpreting a satellite image, you can interpret various objects. You can interpret various objects, like for example, this is a canal. How to identify canal? This is a canal and this is a road. This is a road. Now, how to identify, how to differentiate between a canal and a road? The road is both are linear features. Both are canal and road are both are linear features. But roads will have sharp turnings on this. Canal will have smoother gradual curves. Canal will have smooth gradual curves. There are certain questions that you are posing. I would prefer to answer them at the end, right? Maybe you will figure out from the session how to identify breaks or how to identify objects with same color, shape, texture. So maybe you will be figuring out, right? And I will come to the questions little later. Okay, so you can see that though this is a grayscale image, a black and white image, you are able to identify the canal, you are able to identify the roads, you are able to identify this is a stadium, right? A circular, bigger, based on the shape, the size, right? And maybe this is the circular track, racing track, right? So these elements you are able to pick up. The agriculture fields. Within the agriculture fields also you are seeing different shades. You are seeing different shades. You are seeing the pattern of these small roads, the field bunds, etc. You are able to see that, and small roads for reaching the different agriculture fields. And you can also judge the status of crop, though not very clearly, but from the gray shade of this the field. Right? So you use these 9 elements of interpretation, right, to identify different objects. So when I showed you earlier a railway station, now you can see the another railway station, which is Hyderabad Nampally railway station. So you can very clearly see the platforms, the trains, the sheds over the platforms, yeah, shades over the platform, and you can see the railroads and the trains on this thing. You can also see the parking lot, right? You can see here not the parking lot where the people are just coming, and yeah, some cars, vehicles are parked also. So this is that parking lot, and this is that railway station main building. You can see here the porch and this building, and you can see here. In fact, you can also see these tomb-like structures, here small tomb-like structures, right? So this is the railway station. So you are using not only one element of interpretation, a large number of elements: shape, size, tone, texture, pattern. So you can see that this is a road and not a railroad, because you can see vehicles on the road, right? Road intersections, road crossings, major roads, minor roads, colony roads, etc. You can differentiate with using different elements of interpretation. You can see the green color corresponds to the trees, and the grasslands wherever mainly the trees are visible, and you can see some grasslands also having a different texture. So texture is a property it is visible at a scale. If you zoom further, if you go near to the object, right, texture will be more observable. And when you're going away from the object, the texture will merge with the back. So okay, so now this earlier also I asked you what is that object. So that object on my first screen of image interpretation was a mountainous road, a highly curvilinear mountainous road, highly curvilinear mountainous road. Now this one also is a mountainous road. You can see that this is Mussoorie area near to Dehradun. Right? So from Dehradun we are coming. This is a lake, popular picnic spot. So this is a lake, and we all go highly mountainous area. So you can see the pattern of roads going up and down. Small towns in between, small areas of residential areas in between, and highly mountainous roads, right? And you can see the pattern of trees, texture of trees is evident. The colors in these are the different buildings, right? So you can see bigger buildings, smaller buildings. Right? They are schools, residential areas, hotels, etc. So this is a summary of elements of interpretation: shape, size, tone, texture, pattern, shadow, association. So you would be using more than one element of interpretation to identify different objects in one scene. So this is referring to visual image interpretation. Now this was very detailed, high resolution image. In the morning session also, I saw that you have been told about false color composition. Now you have been told that remote sensing data is multispectral in nature. For the same area, data is captured in different wavelength intervals. And the true color composite is when we are capturing the data in red, green and blue and displaying them in red, green and blue. Right? So this is true color composite. You see vegetation as green, water as blue. Right? So a false color composite is a standard false color composite is one in which we are using the near infrared band. Near infrared band we cannot see with our eye, but it has very unique properties which can be used for interpretation of various elements. So this false color composite is using near infrared, red and green, and this is the combination which comes. It is called standard false color composite because an interpretation key has been developed for this. In this standard FCC, vegetation will always come in shades of red. You see vegetation as green because we cannot see the near infrared. And when we display it, if we display the near infrared on red, we will always see the vegetation as green because vegetation reflects infrared. Water will come in varying shades of blue to black, right? Because water, if you have been told in the morning, water does not reflect infrared at all. Whatever little reflection is coming is from the sediment. So depending upon the depth of the water will be from dark blue to black. Urban areas will be almost steel gray color because they reflect equal properties of near infrared, red and green. So urban areas will be gray, right? And gray, as you can see here. Vegetation will come in varying shades of red depending upon its height, about its density, right? Health of vegetation and so on. So this is a famous area near the Dehradun, the Asan Barrage and the Dak Pathar Barrage. Right? So we will be seeing our experiments on this area, and you can see that the red color is the forest area, wherever the forest trees are. And wherever the forest is depleted or barren forest, it is gray, this dark color is coming. This is agriculture area. Wherever the crops are there, it is coming in varying shades of red. Wherever it is harvested, the field is moist, it is coming in the steel gray, this greenish shade. And wherever there is only dry soil, it is coming in white. And this pattern you can see at the road intersection. This is your urban area. Now you will see that urban area shade and riverbed shade is same because of the same building material. Water body, as I mentioned, will be dark blue to black. You can see the barrage has very deep, so it is the water is deep, so it is totally black. And moist, wherever it is, the colors are changing here in the scale. So now this is visual image interpretation. Now we can also process the image digitally. The image is made up of digital numbers, and those numbers can be manipulated. Right? Even the satellite image which we capture, it can be interpreted visibly, and it can be done with the help of the software. So when we have the software, when we use the software, our digital image processing, we do it mainly for three reasons. Removing errors, right? Compensating for data errors. This is called as pre-processing, right? And here we correct for the radiometric and geometric errors. Image enhancement is improving the visual content of the image. Whenever you want to do visual image interpretation, if the contrast is poor, if the objects are not very clearly visible, you improve the contrast of the image. You do filtering to extract certain information out of it. You transform an image totally to extract certain unique information. And if you remember in the morning session, you were being told that classification can be done. A land use land cover map can be made. A forest map can be made. A thematic map can be made from the remote sensing data from the satellite images using supervised and unsupervised classification. So now this one session is very small to give you a detail of this theoretical concept of image processing as well as visual image interpretation. And mainly this session was designed for experiment based. That means hands-on kind of thing. So we will do a kind of experiment. Okay. I will come to my software. So I am using a software. Let me minimize my slides. Let's also minimize this. So now I am using a software called as IIRS Imagine. You can use any software. If you remember in my slide, I said that a digital image processing system will consist of a computer system, like I am working on my computer system, and I should have a dedicated image processing software. There are a large number of image processing softwares which are available. Some are free and open source like QGIS, right? And some are license based, right? So in our institute, we are giving training mainly on the IIRS Imagine for image processing. So this is the software that I use. Now this software has different modules, and first thing I should do is I should be able to visualize an image for interpretation, right? So that can be done using this viewer. So this is the viewer in which I can display an image. So now in the morning session also you saw true color composites, and in today's session also I mentioned true color composite and false color. So first I will give you an experiment on that, right? So what I will do is, I will first open my photograph, an old photograph. Right, this is my photograph, my passport size length, you can say, that I've printed. In this photograph, if you see that I'm using a, I hope the size is good enough. Okay. So this is my photograph. If you see that I'm wearing a dress which is yellow in color, right? Yellow is my main prominent color which is visible, right? And you can see that there's some background of green tree, yeah, right? And you can specifically note my dress, the background tree, and the color of the hair. To give you an example of true color composite and false color. So this is a true color composite. It is captured in red, green, and blue. So, and it is displayed in red, green, and blue, right. So if I use, now if I want to show you a false color composite in this image only, if I change this 1, 2, 3 and this to 1, now you can see it would appear as if I'm wearing a cyanish color dress. And the trees are green only, but the color of my dress has changed. So this is a false color composite. The dress that I was wearing was yellow in color. So this is a composite. That means when you take a picture, you display it as red, green, and blue. In different bands, you can put any layer and your color will change. Now you see, if I make this 2, 3, and 1. So it appears that the dress that I'm wearing is magenta. And now you see the color of my hair, right? They have turned greenish, right? So I have not colored my hair to green. I have not painted my lips to this color. It is only a false color composite where I'm displaying in different colors. So, and let me make another convention: 2, 1, and 3, right? So you see, you can play in the software and see different color. Now you see in the background, the leaves are not green, right? So this is false color. This is the how to experiment on false color and true color. So similarly, we have satellite imageries. We have satellite imageries here. So this imagery is a false color composite of that Asan Barrage area. This is Ponta area, Himachal Pradesh, and this is Uttarakhand. Asan is at the boundary of the Himachal and Uttarakhand. This is Uttarakhand and this is Himachal Pradesh. So this is a barrage which I showed you earlier in this presentation. And these are forest areas. So dense forest, open forest, riverbed, reservoir, a canal, road, right? So now if you understand how to differentiate between the road and the canal, I already mentioned. Urban areas, you can see urban areas, a clearing in the forest, many agriculture areas with different status of crops. Now this is a satellite image. I can see its information. This is a 4-band satellite image. This is a 4-band satellite image, band 1, 2, 3, 4. And 3 bands are displayed at a time, 4, 3, and 2. Right? 4, 3, and 2. So I can see its histogram. Histogram for layer 1, histogram for layer 2, histogram for layer 3, histogram for layer. And it is made up of these pixels. So this is the visual representation. The image is the visual representation of these pixels. Now here also I can change the colors. Right? So I can make it 3, 2, 1 combination. Now this is not coming in exactly true color composite because list of data, if you look at the spectral resolution, the first band is from 0.45 to 5, right? And the second one is green and the blue, red and red. So that is why we are not seeing this part as green, but agriculture area we are seeing. Then this is I will zoom at the reservoir. I will zoom at the reservoir. Now this image, I will come to the standard false color composite because it's easier to interpret as standard false color composite. So this is reservoir, and this 2 data is spatial resolution is 36.25 meters. For the same area, I have different images. I will show you for the same area I have loaded. Okay. So this is the panchromatic area of the same image. And if I zoom at the, so you see panchromatic data will always be colorless. It will be in gray shade. But now you can see this is forest, the same forest, the canal. Right? This one, if you see here, the canal portion, this is the canal portion. This is the canal portion. This is the road crossing over the canal, right? And you can see the riverbed. So water channels are dark, here they are blue, and here they are the riverbed is cyanish. Here you can see riverbed sand is very white, right? So we can always make an interpretation key. We can make a table, feature on the ground, feature on the panchromatic image, feature on the list 2 data, list 3 different band combinations. We can make an interpretation key, a table. Now, as I was telling you, look at the reservoir. So in panchromatic, it was difficult to interpret the reservoir. Only because of its shape, we have been able to identify it very at the first instant, right? So here the reservoir is interpretable on the color. Here you have to use other element of interpretation for visual interpretation. Now this panchromatic image is at 5.8 meter resolution, and this one is 36.25. Now the same 5.8 meter resolution I will show you in color. So this is my panchromatic, this is my same image, that means 5.8 meter resolution, list 4 data set at 5.8 meter in color. So now you can see that it's so easy to interpret different objects in color. Second thing is that there is a time difference between these images. List 2 Ponta was my 1990 image, and this is 2000. The list 4 is from 2030. So many changes also may have occurred over the period, right? If you can see the density of the forest, the density of forest has changed from 90 to 2013 image. You can see that. Similarly, if I zoom out, the agriculture area has decreased and the urban area has increased. Even other than the protected areas, the clearing in the reserve forest, so many changes have occurred over the period of time. Now this is 5.8 meter resolution, and let me display it at 1:1 resolution. So this is my 1:1 resolution. Now I have other images of the area, sentinel image, and this image is at spatial resolution of, let me check which one I have displayed here, at 10 meters. Right? So 10 meters, and this is 2019 image. This is 2019. So over the period, again, as I said, if you observe the agriculture, the urban areas have gone on increasing. The urban areas, if you observe, they have gone on increasing in different times. Okay, so this is first thing, visual interpretation of the satellite data. Normally, we prefer to interpret visually the standard false color composite. Now, digital many analysis can be done. Like for example, if I use this image of 2019, which is the latest image that I have displayed, in between, let me also show you a list 3 image. List 3 is 23.5 meter image, and this is at the, it has 4 bands. The 4th band is a SWIR band. You can see the color composite that you're getting is different. So if I change the color composite, so 4 here is SWIR, 3 is near infrared. So 3 to 1 combination here will be false color composite, and this is at 23.5 meter resolution, and this is a 99 image. So I have used a wide variety from 1990 to 99 to 2004 image to 2013 image and a 2019 images. The data sets I've tried to show you for the same area. Now, if I use any one screen, let's say, this image which I'm seeing here, it was not like this, right? What the image was, if I open it again, list to Ponta, list to Ponta image. Now, if I simply open it, it will open it. But if I go to raster options, I say no stretch. So that means show me the raw image. This was the raw image. Now you see that the objects are not interpretable. Even if I zoom it to the full screen and fit image to the window, it is so dull. I cannot see objects because the image is having very narrow range of values. The radiometric resolution, due to the radiometric resolution, if you see, the histogram is very narrow. The values are somewhere between 0 to 50. So very dark portion, a low contrast image. So how to improve the contrast? So we can go to the raster and improve the contrast using the either standard deviation stretch or using the histogram equalization. So these are the enhancement techniques. Now remember that the small image which was not enhanced was sufficient for computer to do classification. It can do supervised classification, it can do unsupervised classification, but for visual interpretation, we need to enhance that image so that we can see different objects. So this is called as contrast enhancement. This is called as contrast enhancement. Now, second thing which I would like to show you on a high resolution image, maybe Sentinel. Okay, panchromatic would be better, 5.8 meter. Now, second thing which I want to show you is filtering. Filtering is done to remove errors. So it will smoothen the image. So it will make it blurred. If I open the pan Ponta and then if you compare it. So if you can visually see, this is a very sharp image and this has been blurred. So this is the smoothing which I have done here. I can also sharpen it so the edges become sharp. I can extract the edges. I can find out the edges. Right? So you can see that it is finding out the edges. I can do many type of filterings here. Right? I can do a low pass filtering, which will smoothen the image. And I can do a high pass filtering, which will extract boundaries. Right? I can use a bigger kernel, right, to extract bigger boundaries. I can do edge enhancement, right? And I can do a Sobel filter, which makes edge maps. Right? So these are the enhancement categories. Now I can also do a band ratioing, right? Where I divide one band from another, from one band to another, and extract unique information. So that means I have to have at least 2 bands. So you can see that I can use any one of the image from here Let me use the list to Fonta only to demonstrate. And I can do interpreter and I can do the spectral enhancement indices. And I want to use recent list to Fonta, and I want to do NDVI. And I want to do NDVI. And I say I go to I will make a temporary file where I can store the results, and I say NDVI. So NDVI is a normalized differential vegetation index. This image extracts vegetation out of the my remote sensing data. Infrared bands reflect vegetation very highly. Red band, there is a dip in the vegetation. It's an absorption band for vegetation. So when we take a ratio of the infrared by red, vegetation gets highlighted. So I will show you that. So I calculated NDVI recently. Right? And if I simply display it, it's a black and white image. Vegetation becomes very, very bright. Vegetation becomes very, very bright. Right? And if I color it, display it in pseudo color, I want to color it. Now you see here, vegetation comes in red. Vegetation comes in red. River body is in one color and the land is in one. So in three colors you can display this. And if you compare it with the black and white image, you see vegetation is very bright, river or the water content is black, and this land is grayscale. Because you see water body doesn't reflect infrared. So band 4 divided by anything will be black. So it will be black. 0 divided by anything will be black. Then the sand, the soil, you can say they are having similar reflectances in the near infrared and the red. Please refer to the spectral reflectance curve of different objects. Must have been told to you in the morning session. So they become grayscale and vegetation gets very high values in the ratio. So this is one kind of enhancement and this is transformation, right? So if you remember, I written contrast, I've given you a demonstration of contrast, filtering and transformation. So now I will tell you classification. In the morning, you have been told about the classification and you can make a land use land cover map out of the images. So I will close unnecessary windows and we will do classification. So it will be easier to classify the list to Ponta again, let's say. I will use this image to classify. Okay. So now in supervised, there is supervised classification, there is unsupervised classification. So this means the algorithm will there is unsupervised classification algorithm which will group similarly reflecting pixels, right? And supervised algorithm will make a land use land cover map. So I will give you a demonstration of both of them. I will give you a demonstration of both of them. I'm trying to search for a smaller image so that my processing is not slow. I will open another image. Okay, so this image that I have opened is a list4 image, 5.8 meter resolution, right? And the 3-band data set, right? So in supervised classification, the steps are that I have to first mark a training sample. Supervised classification is the classification in which we will mark training samples. Samples of known identity will be used to classify pixels of unknown identity. So I will tell, as an analyst, I have an idea about this area. So I will mark training samples in this signature editor. That means I'm telling the algorithm, my specialization, that this is this class. So I will use here UI tools and I will mark here a area. Right, so this area I have marked, I will add it here and I will say that this is forest. And I will give it a color. Forest, I want output as green. Right? And this is one sample that I have marked. Then I will mark one sample here. And I will add it here. And I will say this is a water body, a reservoir or a water body. And water, we would like to see it in red color, sorry, in blue color. Now let me mark this riverbed. So river. I would like to see output as white color. Right. Okay, then the dense red patch we have marked as dense forest. This patch we have marked as dense forest. And if you observe, there is some dirty patch here also. I will try to mark it as open forest or degraded forest. I will say open forest or degraded forest. And let me show it in different color. Then I have the urban areas. I will mark the urban areas. Generally in a map, urban areas are shown in red. And you see there are different agriculture fields. There are different agriculture fields. Some are with crop, some are without crop. So I will mark some of them. So I will say it agree without crop. And I will give it, okay, the color which has come on its own, I will use that. And I will use area like this. And I will say agriculture with crop. Agriculture with crop. And I will mark it as yellow color. Because in maps, normally the agriculture is marked like this. So now this is so these are the training samples that I have provided to the software, saying that these are my classes, and you make a complete land use map for this area. Make a complete land use map for this area. So then I should save this file all, and I should save it and the folder which I made in the temp folder. Okay, and I will say supervised classes, and I say okay. Now I can do classification. Classify supervised. Right. So output file, I can go and make it in the temp. There are a number of classification algorithms. I will show you maximum likelihood and I say okay. Maximum likelihood and I say okay. So the software is processing. You can see here. So it has finished processing. I can open and recent files, maximum likelihood, and I say. So you see this. So this software has made a land use map for my area. So dark green, if you remember here, we had marked them as dense forest. Light green was open forest. The riverbed was white. Urban areas in red. Agriculture without crop was this green color. Okay, colors are matching, mixing. So agriculture with crop was yellow. So this color, let me make it purple. Okay. Okay, this is in this thing here. I should make it purple. Attributes and this color, I want to see it as purple. Right. So this is my classification technique. So at moment I could only give you an overview of supervised classification. This classification may have many errors, right? Some classes may be mixing, right? Like you can see that the riverbed is shown as agriculture because the signature that I marked, right? The building material is same for urban and the riverbed. So wherever it was conflicting, they have overlap. Right? There are techniques to resolve them. But here it is only we are giving you an overview. So we will discuss that in later courses. And so this here, if you see that I have done a supervised classification with 7 classes. What if I want to do an unsupervised classification? Right? I want to do an unsupervised classification with 7 classes. So I go to classifier, unsupervised classification. Input file, recent, this was list for dark pattern. This image was list for dark pattern, and I say okay. And I want now 7 classes because I'm comparing it with my supervised. Go to temp and I say unsupervised. Right? There are different algorithms here also. So once I get 100% processed, okay, now I can open the unsupervised and compare it. Unsupervised. Right, so you see, this is my unsupervised classification results. Now, this is, I can change the attributes. And here also I can change the attributes. Now here you see, and where are the attributes gone for this file? Raster attribute here. So raster attributes for the maximum likelihood, raster attributes for the unsupervised. So this one color is, let me make it white. So this is almost water, so I will make it blue. Now you see here, first difference between the two tables. First difference between the two tables is that my supervised classification maximum likelihood which I use, it is giving labels to these pixels. It is labeling that this dark green color is forest. This blue is water. But here in the unsupervised, this blue color cannot say it is water. It is only saying it is class 1 because the algorithm doesn't have, the unsupervised algorithm doesn't have that intelligence that this is water. It is, I as an analyst will have to tell it, it is water. And if I wrongly tell it this is not water, it will say it is not water because it can only say it is class 1, class 2. Right? But here you see the difference here is when I made natural groupings, more water is correctly classified. When I gave the signature, I may have made the mistake and given some wrong filled pixels as the sample. So that is why I have very less water in my supervised, whereas more water in the unsupervised classification, because here it is doing its own grouping. Then this one, let me change the color and see. Okay, this is water only. Then this class, let me change it to red. So this is approximate open forest. This one, let me make it dark green. So dense forest. This one, I don't know what it is yet. Okay, so these are the patches in the riverbed and some agriculture areas, kind of. The gold land. So here we have to try to identify which is which class. So the classes and the pixels will never match. Okay. So this is mostly riverbed. Right? So this is difference between supervised and unsupervised classification. So this was 1 hour session on the experiment of reading satellite image, both visual image interpretation and digital image analysis. This was a small overview of the big science that it is here and very interesting science. And now we will break for the questions. We'll break for 5 minutes and then we will start the interactive session and take your questions.